When it comes to ventilation, there seems to be so many terminologies, so many type of ventilation, so many focus, functionality, and what's not. And to make matters worse, the adherence, the necessity to adhere to legal compliance, and the introduction of various terminologies and concepts and limitation by industrial hygienists or service providers has created a big mess, and at times it also messes up or it also affects the actual basis, objective of why the ventilation is being installed in a particular area in the very first place. Hi, my name is Harrison Prabhu. I have experience in ventilation engineering. I'm about to share with you some functionality terminologies in proper understanding of the functions of a ventilation system. Now, first of all, let's look at this. Let's look at what is ventilation. Ventilation is basically all about movement of air from one point to another point, and we're going to use this phenomena of movement of air. Movement of air takes place because of pressure variance from one point to another point. So when that happens, or because of temperature variance from one point to another point. So because of this particular variance, or because of this movement, we can capitalize that to sort a lot of things. What sort of things we can sort of? We can use this movement to mitigate thermal stress. We can use this to basically combat emission and suspension of airborne contaminants. We can use this phenomenon basically to create thermal comfort and what's not. It's a matter of how the whole air movement mechanism is being used in a particular design. Now, let's look at the common terminologies which we have, or the common type of ventilation we have. You have a natural ventilation. Now, how does a natural ventilation work? A natural ventilation works based on movement of air from high temperature to low temperature. So that's how it works. So when we have high temperature outside due to sun radiation and what's not, that air would want to come into your house. So usually it will enter from the window of your hall or the air vent from the kitchen it comes into. And when it comes into your room, so it eventually gets heated up with all the heating elements in your house, from people, from probably some from your TV, from your refrigerator, from your iron, from your oven, from your microwave, and what's not. So all this will heat up the air, and the air will become lighter. So the buoyancy will increase. It will eventually go up and will get released from either the air well or the roof ventilation system and what's not. So that's natural ventilation. So how do you enhance a natural ventilation system? You control, you ensure that the windows are adequate, the windows are nicely open, so you allow the induced air to come inside. You ensure that there is a good air passage. The building is designed in such a way where there is air passage. You make sure that you do not block your air wells. You ensure that there are elements of pressure variance. You do not fully open all the windows on the top floor, and probably you shut you maybe control the closure of all the windows on the top floor, and probably increase a bit the one from the bottom, so that more air will come inside, more air displacement will take place, more air changes will take place, and this will also control the movement of buoyant air or lighter air towards the air well, so that air changes can effectively happen. So when we understand the natural ventilation system, we know how to make use of it to our benefit. Now let's go on to a ventilation system which uses mechanical force, right? We use fan. So now we have, let's look at general ventilation. General ventilation can be divided into a general exhaust ventilation, or a supply fan, or a makeup ventilation system. So what are these? Now, it all very much depending on the objective what is being made. All right. A general ventilation is basically a ventilation where it push and pull, it supplies and exhaust. But again, it's still very general. It all very much depending on what the function is going to be. All right. Now, when we say makeup air, the function of a makeup air is when you have an exhaust ventilation. When you have an exhaust ventilation, the makeup air will basically replenish back the air which is being exhausted out. So that's what makeup air means. Now, let's go in depth a bit on general ventilation system. Yeah, general ventilation system, usually when a designer wants to design a general ventilation system, what he's going to look at is the volume of the room. That's the very first thing. A designer is supposed to sketch the whole volume of the room. That's the very first thing. Second, we're going to look at how exactly the room is going to be used. Because you see, ventilation designing, it's all about creating the movement of air. I mean, we started off by saying ventilation is a movement of air. Where am I going to run the ventilation air from? From top to bottom, left to right, bottom to top, right to left. I want to scatter it all over. You see, I want to cover the edges and nooks where air is dead, stagnant. So a lot of things are involved. So you draw, you come up with the 3D concept of a room. Next, let's identify why are we doing this ventilation in the very first beginning. Are you having any heat releasing elements, internal loads? All right, heating elements are you having plug points? Are you having equipment which is going to induce, it's going to generate heat? Are you going to have people working? Are these people working light? What the kind of activities they're doing? Are they light work or are they heavy work? Because depending on the type of activity you're doing, the heat release from your body varies. Your body will release higher heat when you're exercising or when you're doing works which requires higher intensity of actions. You see, then we have lights. Lights are another significant source of heat. The type of light you're using, depending on your job scope or depending on the requirement in that particular room. The lux required, if it is basically a kind of room where it requires the usage of light. If it's a reading room, or if it is a library, or if it is a storeroom where you're going to come and pick up products from time to time. You see, so light is going to play an important role. It's going to be a task-based, illuminance required task. So all this has to be finalized first. Then only you can narrow down the amount of heat is going to be generated internally from that particular room. Now that's basically from the perspective of heat. We have not gone into, there's another area I forgot to update, products which are coming in. If that particular room is basically going to work on products or the process is going to have, if it's a laboratory or if it's basically a process where heat is going to be involved, or you're going to transfer products which come from an oven into the room, that product itself is going to create or going to release heat. So we have to look into that. Now let's look into another element, physical element. Heat is a physical element. Let's look at another element, which is a chemical element, which also can dictate how ventilation is going to be used. Chemical element here is chemical which can vaporize and can exist suspended in the air. What is a suspension? Ability to linger in the air for a very long time. It doesn't settle. You see, anything which settles is not going to be a nuisance or it's not going to be an occupational hazard. It's not going to be a problem at all. But anything gets suspended. You see, from the terminology of industrial hygiene, anything which is less than 100 micron has the ability to get suspended. If you take an A4 paper, if you drop that A4 paper, it will take a while to drop. You take a key or a marble, it drops pretty fast. So that ability, that suspension is going to be an issue, because now when that suspension takes place, okay, that's an hazard, right? So what's going to be the risk? A person lingering, occupant being in that room, it's going to get that suspension of the airborne contaminant getting into the respiratory system. And that will get introduced into your breathing zone. Breathing zone is basically something from the nostril. I mean, if you take breathing zone is imaginary sphere of your face. Let's say from your nostril, you take 2 feet. Yeah, try to create an imaginary space. Now the fundamental of exposure control of airborne contaminant is we want to ensure that the suspended airborne contaminant doesn't get into this breathing zone, yeah, 2 feet sphere, a 2 feet sphere, radius sphere. You see, 2 feet diameter, not radius, 2 feet diameter sphere. We don't want your suspension of that airborne contaminant to get into that. You see, so when you have that in place. How do you use the general ventilation? You see, how do you use general ventilation? This whole suspension thing, this whole sphere thing gave birth to local exhaust ventilation system. What is local exhaust ventilation system? Local exhaust ventilation system removes the contaminant away from this breathing zone. General ventilation system dilutes. It can't remove it completely because the person has to be in their room. But what it does is that entire introduction gets diluted as much as possible. So now all these things are involved in designing general ventilation. Let's get into local exhaust ventilation later. All this come into place when it comes to general ventilation. So when we want to design a general ventilation system, first of all, we need to highlight what are the objectives. Let's identify the heat element, the physical element, the chemical element, then we work on that. The other things which we need to look at is now pressurization in the room. Does the room requires negative pressure? Does the room requires positive pressure? How do I decide negative or positive? Now, if you're going to have chemical involved, you see, regardless of having ventilation system or not, air is either going to come into your room or it's going to go out of the room based on pressure. You are not the only one who's creating pressure variance by putting the fan. You got natural phenomena which is creating the variance. Temperature outside, temperature inside is going to bring infiltration where air from outside come inside. Exfiltration is where air inside to go outside. You see, so that's going to happen. And when you install an exhaust fan and you're not going to install a makeup air, trust me, that's going to create. We think nothing's going to happen. Trust me, that negative pressure in the room is going to create vacuum and start pulling air from outside. So that is why the terminology of makeup air came all about. So when we design, we need to decide, number one, what are we doing? Okay, your generation of air, your calculation or determination of air change per hour is going to be depending on the heat. It's going to be depending on the chemical suspension for general ventilation. Then right after that, we're going to decide, once we calculate the air change, we're going to decide whether we want an exhaust air, we're going to be, or whether we want a negative pressure room or a positive pressure room. All right. But during this stage, you also would want to consider whether you want to use a local exhaust ventilation system. This is where the local and exhaust work together. You see, all these are ventilation at the end of the day. That's what I said. Sometimes all these terminologies and the barriers and limitations we tend to confuse ourselves. No, it's all ventilation at the end of the day, but how we look at it. You see, so I have processes in that particular room, right? Okay. During the initial stage, when I want to do the general ventilation, I realize there are processes. I have a fume hood, for instance, or even I have a plating tank, or I have a grinding process or what's not. You know what? I decided, okay, I'm not going to start out with the general ventilation yet. You know what I'm going to do? I'm going to locally capture this airborne contaminant. I'm going to locally capture the fume which is being generated by the welding process. I'm going to locally capture the particulate matter, the grinding particulate matter which is being suspended at high velocity by using a local exhaust ventilation system. I'm going to capture the vapor which has from that chemical which has high vapor pressure, which gets easily volatile and it's being heated up in the process. I'm going to capture that at the source, at the lid of the apparatus. I'm going to capture all that. I'm going to work on that. I don't want it to linger into the room. So what I do, I create local exhaust ventilation system. So when I create local exhaust ventilation system, what happens to the general ventilation design mechanism? It works. The whole negative and positive, the exposure, the exhaust and the supply works together
to create the overall pressurization of the room, and indirectly it will control the exfiltration and infiltration of the air depending on how we work out the entire settings. Now, at this point, in short, we can summarize. At this point, we can summarize that intention to install a ventilation system has to be systematically approached. It has to have an objective. It has to, first of all, it has to define the stresses. Then it has to quantify. This is always bypassed. We must quantify what exactly the amount of that hazard. It can be either empirically calculated or it can be measured and what's not. Then using this figure, we move on to the next approach of defining the type of ventilation we're going to use. Okay. Another important element which always get bypassed is the importance to save the energy. You do not want to size up a very big fan. The mentality that big ventilation, a high flow rate is better. No, it's not. You do not need a high flow rate. You do not need a big high velocity system or whatsoever. So once that's done, then we work on the next approach, which is basically designing it and commissioning and creating an establishment. While we are doing the ventilation, we also have to take care of the air conditioned system and what's not. So in short, when a systematic approach is done, you will have a successful commissioning. You will have a successful installation. You will have a successful kickoff of ventilation system. Then the next chapter will start. The next chapter will basically how to use the baseline data and operate the system within the acceptable range. The ventilation system does not run continuously without failing. So you have to maintain the baseline, maintain the operation at the baseline condition so that it will run within the baseline condition and doesn't drop below the minimal limit. So this is where the preventive maintenance will come in, and we will cover this in another topic. All right. So do not hesitate to contact us if you have any questions. We are obliged to assist you in any way possible.